know what it's not worth it to ship. If we had a pick and place that only did 1206, that's not worth it to ship. You know?
It's called a crane.
Yeah, that is a crane. Hello, and welcome to the Open Hardware Manufacturing Podcast, the podcast about making open source hardware. My name is Stephen Haas.
And I'm Lucian Chapar.
And today we are talking about writing a PRD, or a product requirement document. We talk about what this is. What do you put into a product requirement document? It's kind of what it says on the tin, but we get into the details about what needs to go into it, what research you have to do to make sure that you know you're building something people care about, writing your constraints and how they should be effectively immutable, and that should be what you make. How can you make sure that you're adding features into your product that you can support down in the future? How do you make sure that your product sparks joy with your customers and make sure you're gonna make something people actually want to use? And also, we invent them up. And I'm gonna leave it at that.
You'll have to see what we mean by that.
Jury's still out if I like it. It's kind of funny, but I like that it's a phrase. Well, you'll see what that is.
Yeah,
it's nothing crazy. And also how to make sure you don't get nerd sniped, because it's really hard to not get nerd sniped, and you got to do the work to make sure it's something people want. You can't just make something that sounds fun to build, unless it's a project. You know, you got to make that distinction. This is a good one. This one definitely informs everything we do. This is such an important thing about making a product.
Yeah, I completely agree.
Yeah.
And not optional for us.
It is not optional.
Yeah.
I don't want to prescribe it to people.
Yeah, you may feel the same way after trying it out.
Yeah, it's
Maybe
good.
you won't.
Yeah, maybe you won't. Maybe you're like, whatever, those jokers, you know, they're doing
Yeah.
extra work, but we like it. It helps us a lot.
Mm-hmm.
Yeah. Anyway, let's get into it.
Yeah, let's do it. Today's episode is about PRDs, or product requirement documents.
Mhm.
Stephen, you want to tell us what that is?
Yeah, a PRD defines exactly what a product has to be and also very explicitly what it isn't. And I think a PRD does its job, and you are respecting the PRD properly in that if your product does not fulfill everything the PRD requires of it, it doesn't ship. It's your rubric for making something. And if you don't hit those points, it is your go, no-go gauge on, do you put this thing out the door?
And we lean on that pretty heavily here.
We do.
There's been a PRD for just about everything we've sold.
Yep.
I'm struggling to think of something that didn't have one. And even Strip Feeder kind of in a way had a PRD.
Yeah, we didn't write a formal one, but like there is a PRD in our brains about like what it has to do.
So, and any like matured company, a PRD is generally the North Star you'll see for like what the product team decides gets made.
Right. And it is a document. It is a Google Docs. It is a Word document that outlines, it has a lot of stuff in it, but first and foremost, it is telling you what the thing has to do. And there's a lot of reasons to have one. Like, we'll get into a little bit of this later. And like Lucia and I both worked at a number of other engineering companies aside from Opulo, and like seeing how they do it differently. And we've settled on this from seeing success and failure with how to use a PRD and like, where is it actually useful and where does it feel like red tape? Like, we're still small. We're still under 10 people, but we spend the time to write this document. It's useful, quote unquote, red tape. You know, it's useful to do it even for a startup.
Because everyone needs to be able to go back to the same document and go, what are we making?
Exactly. Like, you need to write, what are you doing? And we'll get into a little bit more of it later of like, why are you doing it? Is it going to sell? Is also a lot of it. Like, are you fulfilling the problem your customers have? So if you're writing a PRD, if you're going in and you're going to start, you want to make a thing, the first thing that you have to do is a lot of research. Because if you just go, this would be cool, and you make it, you don't know what's important to your customers. You don't know the correct way to go about making it necessarily. Before you actually start doing any engineering, you have to consider a lot of other variables before you dive into it. So the first and most important batch of research to do is about your users. If you make something that nobody buys, that's a project. And that's cool for you if you want to make it. If you're trying to make it to sell it, you better be pretty sure someone wants to buy it.
We see a lot of founders run off deep into the weeds because they get distracted by a shiny thing they think would be cool for the world, and they think people would appreciate as much as them.
Yep. And that's not the way to make sure that you have a company that stays alive. If you're trying to make a thing that you sell and is your job and all that kind of stuff, someone has to want it. And you might find this cool little sparkly engineering side. Like there's a great XKCD about getting nerd sniped that we talk about a lot of, like, you know, you find a cool, interesting problem and it completely distracts you and pulls you in. That is the bane of a successful product. it's really cool to get nerd sniped and it's very fun, but a nerd snipe does not a good product make.
No.
You need to make sure it's solving the problem of a customer. So the first thing is to interview the heck out of customers and ask them, what is the problem? Not what they want for a solution. What is the problem that they're having? Who are they? What's their background? How do they think about things? Where do they hang out? Where do they get their information? What's a problem that they face? You know, it could be any number of things. You have to have a direction when you start interviewing these customers of like, oh, it's annoying to assemble circuit boards. So it's good to have a little bit of information first, but you need to validate all this by talking to your potential customers.
Yeah, and I've seen this work where people just know that an industry has a lot of pain points, and they go interview a bunch of people that work in a trade. Go, hey, what's rough about deep sea welding?
Right. Yeah, what are the problems in deep sea welding?
You don't even have to necessarily know what you're going to make from these interviews, but let that paint a picture and you'll make something meaningful to more people than you would have otherwise, for sure.
Totally. And if you are a deep sea welder and you're like, man, this is annoying, you are uniquely suited to know what that is. You're your own customer, which is kind of the idea of dog fooding, of using your own product too. You know what it's like to be in that position. That's a pretty good starting point of, yeah, I know this is a problem because I'm literally one of the people that would use this thing that I want. Really good place to start out. But that's not enough. You still have to interview a bunch of people. N equals 1. One sample size is not sufficient. It's not statistically significant. You need to interview more people.
And for sure, like, I've watched plenty of Shark Tank. I'm sure anyone listening has too. Like, there's dudes that get lucky.
Yeah. Yeah.
I remember one guy he ran into a safety issue in heavy industrial mining equipment. Like, if I have this issue, others surely do. And he was right.
He was right. Yep.
Another guy made a drill with a quick change chuck that could like switch between 2 bits at the press of a button.
Oh, that's nice.
It was cool, but no one bought that.
Interesting.
He got nerd sniped.
Yeah, he got nerd sniped. Yeah. Yep.
Yeah.
And it's cool. If he wants, there's nothing wrong with building that, but you have to be okay with it just being for you.
Yeah.
You know, or a small number of people that are super stoked on it. I mean, the guy who, Tim, I think his name is Tim Leatherman, the guy who made Leatherman brand tools. He made this thing. He's like, this is really cool. And he tried to sell it to people for like 8 to 10 years or something like that. Really long time. There's a great How I Built This with Guy Raz episode about it. And it took forever. And then finally people were like, oh, this is great. And he just kept beating his head against the wall. Like he did customer research and they were like, I don't need this. This isn't a problem that I have. So sometimes this isn't right. You know, like he was like, no, this is really good. And you just don't understand it yet.
That's funny.
But
I didn't know that one.
Yeah, it's a great episode. He's a really cool guy. Really kind and, you know, generous and interesting person. But it's good to do. You should prepare yourself. But, you know, also the world is full of gray and, you know, ambiguity and who knows? You have to try. You have to ask these people. And you know what they might have said is, yeah, it'd be nice if I had a bunch of tools in my pocket, but I don't want your thing. That's the problem. And he had to tweak the product a little bit to actually solve their problem.
Yeah. Henry Ford listened to a bunch of people say they wish they had a faster horse.
Yeah, exactly. Yeah. That's a great little gem of wisdom, you know?
Oh, yeah.
It's true. What's the problem? You're asking about the problem, not the recommended solution per se.
And then the PRD funnels that all into one central repository.
Exactly. Yeah. So you're doing all this research to help collate all this into one place. There's also, what's the red tape around this? In order to sell something to firefighters, it needs to be approved by this board that firefighters can only buy things with this certification or whatever. You need to know what that is. You need to know what metric is important to these people. Chips per hour, 402 support. These are things that we learned early on when I was doing research years ago about this.
Qualitative and quantitative metrics here.
Yeah, that's a great way to say it. First, the people going, this is annoying. And then the stories, the anecdotes, and then the metrics. What's important, you know, numerically as well.
Yeah, I'm sure we'll get more into that later. Being able to measure your success and how well does your product fit the requirements of a PRD is something that becomes important here.
Yep. Yeah, this is going to inform the next section, which is the, what are you making? This is still on in the research section. And then also it's good to look at modifications. If people are kind of drifting towards, like if someone has an existing product and they mod it to do something, well, that really informs that they still have a problem with an existing solution, right? Like if you look at our V2 and V3.0 lumens, people made linear rail mods and they're like, yeah, I want this thing to be faster. I want it to be smoother. And so we added that on. Like modifications are a great indicator of like, what do people want? You know, if they spend the effort to do something like that, it says a lot.
Yeah, it's kind of like a desire path, like the dirt path in a paved road.
Yeah. Like if you see all the dirt paths across a college campus or whatever,
Yeah.
That's where people actually choose to walk, maybe not on the sidewalk. Like that's where you should pave.
Mm-hmm.
Yep. Those are good things to do when you're talking to your users. You can also look at existing solutions. If there's, so, pick and place is obviously our yardstick here.
Yeah, our bread and butter.
Exactly. But like, what are the existing pick and place options? Why does that not solve the problem for people? Like why would they choose to get one or why would they not choose to get one? What's a problem with the existing one? What's great about the existing ones?
Mm-hmm.
Is there space in the market for it? Is there a great de facto solution? Everyone's like, nope, this is awesome. Like this is it. Or is it frustrating to people?
Yeah.
Does anyone need this thing you want to build?
How much do people like their tweezers?
Yeah. Right. If universally humans loved the idea of picking up tiny components and placing them onto PCBs, yeah, there wouldn't be a lot of, if it's as fun as playing video games, there would be no pick and place machines.
An iPhone would be $10,000.
Or it would be $3.
That's funny.
Well, I don't know. Yeah, I think it'd be cheaper because the work is way easier. It'd be expensive for other reasons.
We just trained crows to do it. Sorry, I'm getting us distracted.
It's okay. It's a funny point. It's like you have to know that there is a problem. Is there something annoying? And being annoyed yourself, like we said a second ago, is a great way to know. Yep, there's something lacking. This is not good.
So then, like another core component of the PRD is like figuring out that rough engineering architecture. Like, what are the implications of all the different ways you might approach solving these problems you've identified?
Right, and not necessarily like all the implementation details, but broadly speaking. So like when we wrote the PRD for the version of the Lumen we're working on right now, and we were like, okay, we could do Core XY or we could do XYY, which is what we called it, where we have 2 Y motors and then 1 X motor. And this is a great example of like rough engineering architecture. We haven't designed it. I haven't done the Marlin mod for a Core XY version, but we did the math of like how much faster could we move with Core XY? What are even the packaging implications? If we do Core XY, we have a fully routed belt system and the huge XY footprint of the Lumen. We don't want people to route that belt themselves. We now need to ship that full footprint somehow. Packaging goes up a ton, shipping goes up a ton.
Yeah.
So like these are these early decisions you have to make looking at the kind of the whole aspect of shipping a product when you're making these decisions. And so, we did the math on, is it faster to switch to Core XY, blah, 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 all that stuff.
On that one, we really scrutinized. It's like, is it worth figuring out the packaging changes?
Yep.
And just doing this back the napkin math really helps you drill down into like what you want to make.
Right. Yep. Yeah. It really does.
There was a 3D printing company both Steven and I may or may not have worked at. And there was a 3D printer being engineered, and it could not be heavier than 70 pounds and like 30 inches in each given direction, because past that, it was freight.
Yep. And that was maybe not a no-go on shipping it, but if it were, you cannot exceed that. That needs to be considered from day one, because if the entire architecture of the machine relies on it being 75 pounds, you're dead in the water. You need to know that before you start. So if you're not thinking about packaging before you start engineering, unless you charge, $200,000 for it, we will just manifest it there somehow. Like it's minutia for shipping.
They drop crate with a parachute.
Right. And that's unlikely.
Yeah.
So
we work in the real world here.
Yeah, exactly. Yeah. So, and we did the trade-off. We get into this a little later about like actually writing the constraints, because this is all still research of like, if we do Core XY, we know we do not want the customer to have to route that belt themselves, because that sucks.
Mm-hmm.
And it would have to be this big. So, and then I made this whole Excel sheet of like graphing out, what are the speed differences of Core XY versus XYY. Actually, XYY ended up being better in almost every regard because we have 3 motors instead of 2, which was interesting. I wasn't expecting that. In retrospect, it's more obvious, but you think Core XY is just great from printers doing it, but kind of a tangent.
Yeah.
But we saw, okay, we could do Core XY and it's this much faster. We could do XYY and it's this much faster, whatever. And we're just kind of getting the numbers. We're still not making assumptions about what people would want. We're just kind of getting the research about all the different ways we could architect it and ship it.
The beautiful thing about figuring out your rough engineering architecture is it begins to paint a picture for you to color in with your details.
Mm-hmm.
Like, you and I have this notion of like constraints are a really cozy straitjacket.
Yep.
And we're in figuring out your architecture here, you're deciding what's the shape of that jacket.
Right. Yep. Exactly. Another way you could think about this too is like, how much build area does someone need on the Lumen? And what's a standard size of a table? If it's 35 inches deep, and it's actually very hard to find a table that's 35 inches deep. Well, that's kind of annoying for mostly everybody. It's hard to find a table for it. The Lumen is explicitly as big as it is because it fits on a desk.
Right.
Like, we didn't make it any bigger. We chose that size because it fits for that use case. So that also kind of plays into this of the engineering approach of like, okay, is it big enough that it's still good for useful work, but small enough it could still be on a desktop?
And for us there in that example, we went to IKEA, we went to Home Depot, we went to a couple other furniture outlet stores, and we measured the average desk.
Yep.
We looked in Europe and saw similarly, what's the average desk there? Like, that's all relevant to the PRD.
Yep. Yeah. And, even just some of this is even a little gut check of like, we built up some early frames of, trying different sizes and just seeing, because the early ones, I took a shot on a size, but we kind of reassessed it later on. And it's like, yeah, it has to feel the right size too. If it feels too big and cumbersome, that's going to be a thing as well. So all of these, like, what are all the extra implications it can do? And yeah, value added to the customer. If you make a choice that gives you like, I don't know, like a 5% increase to the customer's value of the thing, but it's a 60% complication to the design or the manufacturing or the cost or something, do you do that in that version? Is it worth it to them to pay an extra X amount for an expensive thing to get that extra 5% value or not? And that's part of doing the research to talk to the customer.
Now you've painted a beautiful picture. You have your engineering architecture. It's time to figure out like what exactly are the variables here.
Yeah. How do you take all the information that you gathered and find a thing that kind of like checks all the boxes?
This leans heavily on the research you've done, all that conversation you've had with users, talking about what's viable to build and ship as a product.
Yeah. If the thing that you want to make that customers want costs $3,000 to build and they only want to spend $500 on it, that's not viable. And it requires, $300,000 worth of, facilities and architecture and clean room for you to facilitate, and you don't have that money. Yeah. It's not viable.
Or let's say the customer demands a machine that moves at a certain speed with a certain amount of horsepower that you can't get from the North American wall outlet.
And they also don't want to hire an electrician.
Yeah.
Or unplug their dryer.
Introspect.
Yeah, introspect. Yep, exactly.
Yeah. And then I'd say if that's the situation you're finding yourself in, probably go back to that rough engineering architecture and figure out what do you really need to make again.
Yep. And maybe that's why there's a void in the market. Yeah. There just isn't a good solution yet. The technology has not gotten to the point, or you need to build the technology that you can move that fast with a standard wall outlet.
Yeah, we've been seeing that doing research about reflow ovens. There's a North American 115-volt outlet's a doozy.
Yeah, you're really pushing that circuit.
Yeah, so like towards that, sometimes when looking at the full constraints you have to work around, you might realize there's features that need to be dropped. There's the trade-offs that might not be worth it. Mm-hmm. It's always a balance.
Yep.
Like the iPhone could always have been more engineered, more fancy, more bells, more whistles, but they're engineering at a price, a certain UX, a certain architecture.
And a certain place they want to be in the market. Some people make really good money making, like, Creality is a great example versus Prusa. Creality makes very inexpensive printers, and they aren't quite as plug and play. But that's the market. Their PRD is for the hobbyist entry-level 3D printer. That's who they're selling that to, And then Prusa and Bamboo Labs and like the more expensive ones, they're thinking about someone who will spend more money. Money is less of an object, and it's more plug and play. That's who their PRD is targeted at. They have a different customer. Different products can go to different customers. The Mini's different than the i3 or i4 or i3 Mark IV. Jeez Louise.
Tongue twister.
Tongue twister, yeah.
Go back to naming.
Yeah. Oh, no. No, we're done with naming. But there's nothing wrong with choosing that market. You just have to be explicit about who it's for and what do those people want. What's checking the box for that group of people. And you might have to make some punts. It's going to go slower, but you know what? It's cheaper. It's a less expensive printer. You might clog more often. But you know what? It was $180. Yeah. So, and that's okay for that market. They're all right with that cost for value,
Let's assume that what their goal is here. It's to get people into 3D printing who wouldn't have otherwise been. It's not necessarily to offer a clandestine 100% uptime printing experience.
Right. And if you can get a clandestine 100% 3D printing experience at $180 price point, go for it.
Yeah.
But, if you have to make the trade-off, do it with the context of your customer and what they want. We run surveys of what people care about in a pick and place. That informs what we spend time working on in the machine.
Yeah.
100%. That's what they care about.
And for us, it's reliability and accuracy.
Yeah, consistency above all else. And that it's not to say that other things aren't important. It's just to say that that's the most.
Yeah.
That should be the priority. So you have to play the trade-off game. Everything is going to be a trade-off. We live in a world of hard written physics rules, and you cannot exceed them. You cannot have everything. You have to choose. You have to pick the ones that are important. That's really what makes it the product. It's the execution, but it's also deciding where you choose to pull a punch or really double down.
Yeah. So when considering all the features that stem from the architecture decisions, you then really have to think about the weighting of priorities with these constraints.
Yep.
Maybe the Creality customer would prefer a tinier printer that was more reliable.
Yeah, that's true. That's 100% true.
Spend better money on bearings.
Yeah. Yeah. Maybe they would, no question, spend another $20 on the machine, but it clogs half the time as it would otherwise. Or, that's the kind of stuff you're trying to suss out. And, some of this is implementation bugs, like maybe it clogs because it just isn't designed very well, but maybe it's, an artifact of the material. It's an artifact of how much money they put into the thing. What quality stuff do they buy? It's figuring all that kind of stuff out. When you're also writing your constraints, you also should be thinking about what is important for the future of your product line and support for future things. We talk a lot about not pigeonholing ourselves. We want to make sure whenever we make a decision that is permanent in some way, permanent being we ship hardware to somebody and we have an official version of the hardware. We don't want to preclude them from getting a future feature. As much as we can possibly make sure that it is supported in the future, we do so. And a great example of that is the very first version of the Lumen that we shipped, the V2 kit. It had the front and back rails open and a port on the motherboard that supported talking to feeders. We had not written the firmware for that yet. We had not made the feeders yet.
Marlin didn't even support
the
idea of feeders.
It didn't know what it was.
Yeah.
We didn't have the protocol figured out, but we had that hardware in there so that any future user of the machine could have feeders. And that was in our PRD, was it has to have at least the hardware so that people could have feeders in the future. We wanted anyone to be able to have them.
Yeah.
And maybe that's not important to you. I think I probably should be to be able to support future stuff for, old users. But, you have to be aware of that. What features are you deciding? Yeah, this is going to be one that's really important for us to make sure that we have for future thinking about your product line. Are you planning on having a second version of the machine? Is it going to be able to talk to that? Is there going to be a conveyor belt? Is there a port to talk to the conveyor belt? That kind of stuff. You want to make sure that when you're shipping that stuff, you have it written in there as a requirement. We will not ship without this thing in here.
Yeah, and it's okay to overdo it. The Lumen still ships with features that we still don't support.
Exactly. Yep. Yeah, there are a couple of things still in the machine. It's like, we may not ever support that. It might be still years down the road, but also how cool. This is less about writing a PRD and more about product design, but to be able to ship hardware that you then unlock new features down the road with a software update. How cool. How cool is that? It's a cool thing to consider.
Yeah. Whenever Steven and I are talking about changes to the product or making these types of decisions around constraints, I always stress this caution around not accidentally closing a door.
Yes.
Similar to what you said earlier. But I want to be so thoughtful both of what we're doing, what we're not doing, and making sure that something that we didn't develop is still viable in the future.
Right.
Having breakout for every pin on the MCU.
Right. Yeah. Is there something that someone could use that for that we're precluding them from doing? And yeah, I totally agree.
You just don't want to screw over your future self.
Exactly. Yep. Yeah. You really don't. And if you think about this up front, you don't have to worry about it. You've covered all of the things you're planning to do as a company, as a project. You have thought this stuff through as well as you possibly can when you're writing this, and you'll always get some of it wrong. We change our tune on stuff all the time on architecture approach stuff. Sometimes we've made our bed a little bit and we have our straight jacket of constraints, but we learn as we go and we make things better. But the more you can think about it early on, the more you'll be able to support your previous hardware. So I think this is a really important part of writing your constraints and making sure your hardware has a long lifetime. I know a lot of people don't prioritize this, but I think this is really important to, consider future software updates, shipping hardware that you can add a little magic to your hardware that you ship later on.
I actually think this section's a lot of fun too.
Yeah.
Yeah. You're trying to think about the lumens of past and present and the things you haven't engineered yet. And
sure.
What might I want to do?
Right.
Ooh.
Yeah. How do I leave the door open for it? How do we keep things not ambiguous, but optional?
Yeah.
It's pretty cool. So yeah, that's a huge part of it too. Thinking about future product line, future support for other projects or other machines you want to ship like feeders.
And then, but at the end of the day, you also really need to peg down the exact things that your product cannot ship without.
Yeah. Like your constraints should be the things that if you are looking at the box that has the unit in it and you have a label printed out and you're ready to slap it on there, you should look at every single one of those constraints and definitively say, yes.
Check.
It does that. So yeah, it has to ship. And if you bow on this, as development happens, you might ship something that isn't what people want. You know what I mean? That's why you do this. It has to be, I wouldn't say immutable, because you might learn stuff as you go through development about more what people want or what's possible. You might need to change it, but it needs to be so careful and considered. The reason you write this is to make sure that you don't ship something people don't want. You have to make sure what you put out the door is something people care about and solves their problem. And also, because of this, what you put for your constraints shouldn't be the end-all be-all version of the product. It should be the minimum that still solves the problem, right?
Yeah.
You should shoot to do much beyond what's on your PRD. This is not your best case scenario. This is the minimal version that you will ship. It still solves the problem.
Yeah. What are you willing to stand behind and support for years to come?
Yeah.
Like your name is on it.
Exactly. And you know, with software, you talk a lot about an MVP of a minimum viable product. That can be hot glued together, messy nightmare. But that's not the same here, because if you're shipping hardware, you can't just immediately deploy a new version of the website and everything's fine and you've upgraded it. You're shipping hardware. It has to be better than an MVP.
Yeah.
An MVP can be bad. This should not be bad. It should still solve the problem.
Yeah. I'm trying to think of a better acronym here for hardware.
Yeah.
You think about like viably useful.
Yeah. Maybe not a MVP, but an MUP for a minimum useful product.
Yeah.
Because viable is like, maybe it is. Useful is like, it is.
Yeah.
And that way we can call it a MUP. I don't know if I like that.
That's
but
funny.
Yeah, MUP. You know, so once you get your minimum useful product, it's the one that actually still solves the problem. You might add more zhuzh to it as it goes on, but it has to still be useful. You can't just ship something and have everyone goes, this is bad. This is objectively bad. And then you fix it as you go.
Yeah.
It's a permanent thing to ship it.
Imagine you're building a widget that it leans into like future support for all these moonshot features, but present day as sold and delivered, it's useless.
Yeah.
Like, what is that?
Yeah. Exactly. You can't do that with hardware.
No Man's Sky, though.
But they can do that. They can update it as time goes on. And it got really good.
Yeah.
So yeah, you have to have a higher standard than an MVP, but also let's say you want your pick and place to shine a beautiful rainbow on the ring lights after a job is done. That shouldn't be in here. That's cool. You can add that at some point to the product, but if that isn't part of the machine when you ship, that's fine.
Yeah.
It doesn't have, so don't put it in there. Don't gate yourself from shipping for something that doesn't really matter to customers. It should only be the things that you explicitly won't ship without.
And for Limitless, you'd recommend it for populating a board.
Exactly.
We tried to avoid getting distracted by the the shiny.
Mm-hmm.
No ring light animations.
Exactly. No ring light animations. You know, I think actually in our PRD, we said it needs to support 0603. Because that was the one where, based on interviews with people, we realized if we can't do 0603, it's really not that useful to a lot of people. But if it is 0603, there's a market. And we would still ship with 0603. And we did. And then we got it to 402. It's like, okay, cool. It's good we didn't gate behind that. You know what I mean? You can always improve it later. You can always do other things to help with that support. But you need to know what it's not worth it to ship. If we had a pick and place that only did 1206, that's not worth it to ship. You know?
It's called a crane.
Yeah, that is a crane. That's funny.
But I hope everyone listening can understand where we're coming from here. Like, the PRD is supposed to help you have the assurance that you're working on the right thing. It's to keep your whole team calibrated to each other. And it's just to guide you through the process.
Yep. Once you have your PRD constraints, now you write what the engineering approach is, because you still have to figure this out too. So like we were talking about before with Lumen Core XY, well, the belts have to be all routed together. Packaging is big and expensive. And it's actually a little slower in most instances than XYY, which has a whole extra motor. So we wrote out, okay, we're going to do it XYY. Everything's going to be pre-belted and easy to put together, which was also something we knew people cared about. We had a lot of early feedback from our kits that it was annoying to put the thing together. So easy assembly is really important to people. So we prioritized that. You know, that was part of us making that engineering decision based on that feedback. Yeah. So, you know, you're thinking about, and this, again, this is not super nitty gritty details. This is your basic architecture. What's your motor configuration? What are you using for linear motion? What standards are you going to shoot for and adopt? What parts are you need to be able to pick? Again, all using pick and place analogy here. So why do this? Because this is a lot of work, right? This is a lot of research. This is a lot of writing. There's a lot of stuff that you have to do. I mean, when I wrote the one for the Loom in the most recent version that we're working on, I think it took me like 3.5 days. And this is after research was done.
Yeah.
It was not a short exercise.
But it was immensely valuable, immensely worth it.
Yeah.
I think we to this day come back to.
Yep. And we're a startup. We're a small team. And it's still worth it to spend that much time doing it. It is just such a good thing to do, I think.
And I said it earlier, maybe the same soundbite will survive. But why do this? Just like Steven said, it keeps us all on the same page.
Yep.
It keeps us all focused on the same mission. It keeps the Lumen consistent in its purpose and intent through development.
Yep. Across the whole team.
Yeah.
There are some things we decide up front that we know we never have to relitigate. We know it has to do X, Y, Z. It's not for debate. We decided it early. Everyone chimed in on what's important for the customer. That's not up for debate. It's just not. We're doing all the implementation beyond those core tenets that we know the product has to have. And everyone knows why. If you're like, oh, well, I don't want it to have to support a 402. That's annoying for me for XYZ reason. It's like, no, it matters to the customer. Look at this literal interview we did with the customer where they're like, I don't care unless it does a 402.
Right.
We have a direct answer to the difficulty of implementation.
Very true.
Yep.
I wonder if maybe a PRD, do people less often do it or feel it's needed if they're doing something solo?
Right. Yeah, actually, let us know. Pop into the Discord server. There's a link in the episode notes and tell us if you do write one. Because like we've worked at larger companies, but other startups and stuff. Do you spend the time to write it? What do you put in it? What's your method for doing it? What we should really do is make a template for writing a PRD that we use. Because I already have that template. We might as well release it.
It'd be a markdown file.
Yeah, we could just do it on a repo or something. Because that's what I use for everything. It's a great format and it's from all the companies we worked at and honestly, Thea a lot too. Thea's feedback on how to write one as well. She knows her stuff when it comes to writing those things.
That woman's a genius.
Yes, she is. So this next point is more about if you are in a much larger company, but even then still, Lucian and I make up, we each are in our entirety 3 departments. Lucian is mechanical engineering, manufacturing, and logistics, and I'm electrical engineering, software, and
content.
Yeah, well, and content, I guess. Yeah.
The gram.
Way
more than that.
But yeah, I mean, we come from different perspectives. So like in product, I guess we're both product. But if you write this PRD in conjunction with everybody, there's someone from customer support, there's someone from marketing, there's someone from leadership, there's someone from product, manufacturing, engineering. Everyone needs to be on the same page as writing this, because if it's just product and marketing that write this and engineering's like, that's literally impossible. We can't do it. It doesn't mean anything. If you only have engineering and manufacturing in there, it's going to be really easy to build and it might not do anything useful.
And I know that sounds obvious, but it's incredibly important.
Yeah. Yeah.
I've seen PRDs pitched by marketing product engineers without talking to others. And it comes off as wishful thinking.
Yeah. It's just not true.
It's the most hilarious waste of time.
Yeah. You have to make this thing from everybody, because if you don't, then you have whole departments that don't feel like they're part of the product. They are fighting an uphill battle with something that might be incredibly difficult for them. Like, I mean, even just thinking from a marketing perspective, if the product looks ugly, marketing's going to be pissed. How do you sell an ugly? You know what I mean? Like, maybe it's not a great example, but that has to be something on there. It must spark joy. Someone has to, which is a valid thing. If you have a big, ugly industrial thing and you're trying to sell it to as a consumer product that's supposed to live on your kitchen counter, no one's going to buy it. That's part of the PRD, and marketing and product are going to be part of that. They have to be part of that conversation. So you need to get everybody involved. Everyone's going to have to touch it. Everyone's going to have to deal with the implications of what you decide. You have to make sure that everyone's on board.
Yeah. Make sure everyone signs that check.
Yep. Yeah, exactly. You need buy-in. And that means everyone's going to feel more comfy about working on it. You're not going to have people who are like, whatever, they made a stupid decision. No, everyone's part of this. Everyone made this decision together. We're all on the same team.
Yeah. And in a traditional engineering company where there's a more waterfall style project management, the product and engineering team would hand the manufacturing team a design and say, figure it out.
Right.
And we're kind of here saying that's bad.
Yeah. Because if you have a great engineer or a manufacturing team, 9 times out of 10, they're going to be able to pull it off. But wouldn't it be great if you designed it from manufacturability to begin with?
Yeah.
Like, wouldn't that be way better and smoother and not make your manufacturing team hate you?
There is a brilliant manufacturing engineer at Formlab, Steven and I knew, named Sam. He's now at Neuralink.
He's
and,
awesome.
He kicks butt.
Yeah.
And during like printer early conception, the R&D engineers would bring him downstairs and ask what he thought. Before a PRD was even considered, you still had cross-department talk for consideration there.
Yep. Because if it's not even viable, if Sam's just like, nope, full stop.
We can't do that.
We cannot do that. Like, this is a cool desktop science experiment, but like, we can't make something useful out of this at a price point and a manufacturing facility that we can deal with. No, stop. You will waste any more time you spend on this.
Yeah, crumple up that paper.
Exactly.
Go back to your architectural planning.
Yep. And it also depends on like, I don't know. A part of me doesn't want to say, yeah, this is a difficult thing. Don't do it. Because like, if there's a way to pull it off, yeah, go for it. Like, if you're really trying to do something unique and difficult and new and cool,
yeah,
take a shot at it. That manufacturing engineer should also know what the balance of the company is, in that, yeah, we are okay with taking a crazy moonshot on figuring out how to manufacture a new principle that maybe hasn't been manufactured before. So that person who makes that decision on behalf of manufacturing needs to be in line with the ethos of the company. If the company's like, no, we don't want any surprises, we want plain Jane, easy to build, that's the approach of the company. So this format still allows you to take a big swing. You just need to know what swing you're getting ready for. Everyone needs to be on the same page about that swing.
The manufacturability is something that shouldn't be a surprise.
Yeah, to
the PRD.
Exactly. That's the way to say it. And like, it needs to be on the PRD as, this is going to be a real pain in the ass. And we're okay with that. We're going to figure it out.
And it justifies why it's worth that.
Yeah, totally. Yeah, because you've decided, no, you know what? This feature is actually so important to customers, and it's going to make it really hard to manufacture. This is why it's worth it. Look, everyone says this is important. The only way we get to this is if we have this hard manufacturing thing. It helps with buy-in. It helps with buy-in so much. And feature slip is another good reason to do this. Oh, it's hard. Do we really have to add a port for the feeder? It's a whole extra bit of pins to solder, blah, 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 blah.
I literally said that.
Yep, probably. It's like, no. You know, if you're 3 months in and you into dev and you've already written your PRD and you come upon a particularly hard constraint, and you're like, oh, can we? No, it's the PRD. It's not up for debate. It is written. It is what we do. And you need unilateral buy-in from everybody to change that. It should be non-negotiable. Yeah. And like, if you discover something in manufacturing, you're like, oh, we thought we could do this and we actually can't, and it kind of negates this whole thing. Yeah, you get all the people together in a room and you can change it.
You have a heart-to-heart there.
You have a heart-to-heart. But one person can't be like, this is annoying, and then change the PRD. The PRD is like a screenshot of viable product solution that you need to be able to hang on to. And everyone is assuming is the case.
Mm-hmm.
It also, on the other side of things, prevents feature creep. You might want to add some cool thing, like some funky, interesting idea. But if you don't have your PRD stuff nailed down, don't think about it yet. You haven't done the thing that makes it viable to ship. Do those first. Do the things that make your MUP, make your minimum useful product first, and then add all the sparkly rainbow animations afterwards. Yeah. Even if they're important. If they're not part of the PRD, don't worry about those for a while. And there are asterisks here, right? Because like our machine is like very modular. Yeah. And it's easy to add stuff to it. So like, we can always cut a new version. We can always release this stuff later. But if they
have tightly integrated injection molds.
Yeah.
You can't just add extra bolts.
Yeah.
Like you can't just put an extra sensor in there.
Exactly. So you kind of have to figure out what extra zhuzh you can bake into it through the course of R&D. For us, we can cut a release and then with our MUP, and then I don't know it's kind of funny. I don't know. With our Muppet.
Sounds like a hair system you put on.
It's the new generation toupee.
Yeah.
But, you know, we can cut releases frequently with incremental improvement. But if you have $300,000 tied up in molds and it's tricky to make that change, before you make that mold cut, you kind of have to decide, are we going to have our, you know, metaphorical rainbow animations baked in? You know, is there going to be a bolt for that little ring light somewhere in the machine to do the animation? You kind of got to know. So it's a little harder when you're at that scale, you're doing stuff like that.
Yeah. One thing I'll say here too, like, take the pressure off yourself. It's like, engineer in a way that the machine can be upgraded, right? Like,
yeah,
we have an aux port on our motherboard for more than just, there's one for feeder that we'd plan to connect feeders to, and now we do.
Yep.
But we also have one for who knows what.
Yep. Yeah.
We don't have to figure it out right now.
Exactly. And like, even if you injection mold, like a way you could do it still is you could have a theoretical mounting point that's pretty generic somewhere in your product and you don't populate it. It's just like a DNP footprint on a PCB. You can bake it into the hard stuff of like a PCB design, into the 3D model of the injection molding molds and all that stuff. And then you can decide to upgrade to now it's the plus version. Yeah. And we have figured out the firmware. We happen to populate that board. And maybe you do cut a new mold. Maybe you have to cut a couple new molds to add it. So there's more inertia, but you can still do it.
Even cars do this. The dashboards ship with fake buttons that don't do anything.
Right.
The UI has buttons on the LCD that'll never light up.
Yep.
Not buttons. The UI has icons on the display that'll never light up, but they could.
Yep, they could. And that lets you, if you ship the hardware early, you can add the features later with the software. Like we said before, there are some features on the Lumen. We do a lot of funky stuff with PCBs. We may never use some of that stuff, but if we do, it's there. So, try and do that. If you are doing more of an injection molding angle and stuff, there's a little more inertia to your design. There's still ways you could probably do it, but focus on the PRD first. You can bake those features in later. You can upgrade it later. You can add a firmware update later. What matters? What makes it viable as a product? Do those things before anything else. Think about the other stuff, but geez, that's the product. That's what makes it useful, minimum useful product. That should be the 1000% focus.
Like, if you're listening to this before you've made the jump from like a full-time job to trying to be entrepreneurial, live up an idea, do all of this first.
Yeah.
Like, do this before there's money, other people involved. Like,
yep.
This is the cheap part to figure out in many ways.
Yeah, it can be free. You send a lot of emails, you talk to a lot of people, you do a lot of research, and you kind of determine the viability of the thing. It's not sexy. It's not super fun. I love documentation. I love doing this, but a lot of people don't. So it's not as fun as designing a new circuit board. You have to have resistance against the nerd snipe. Yeah. It has to, if you want to make a thing for fun, who cares if it's a viable product? Build it. It'd be great. But if you care about it selling, you have to make sure it will. It has to solve the problem. It's so important.
The most important.
Yeah, the most important. Because if you go through all that work and you spend all that money and no one buys it, that's heartbreaking. Yeah. Like you have to, that is the biggest de-risk you can do for yourself, is to make sure it's going to be something people want.
Yeah. Once all this is written down, it's a great format too to get feedback from like trusted mentors, advisors, classmates, friends.
Yep.
But if it's all in your head and you're just running towards an idea, it's hard for people to help you. Yeah. Interface with you, work alongside you. It's hard to make a team out of that.
Yep. Yeah. If you have a formal document you can send to someone, like my buddy Alex, I share so many of these things with him. If you don't have an Alex, of someone who is going to be incredibly kind, but also incredibly critical, I know I can give Alex something and he will tell me so directly, this is bad. And he means it with love. That is one of the best things you can get. And then we have a conversation and he goes, it's bad because of this. And then we talk about it. And then things are better for it. If I just kind of barf out my thinking, it's hard to review. If I have a full document written that and I can send to him and he litters it with notes, that is actionable. That is an easy way to compartmentalize what your thinking is about this problem and how you'd like to solve it, and share it with people and get feedback, and people in the industry who maybe know more about this thing than you just started researching. Yeah. It's just such a good tool. We've shared the PRD quite a bit with people, like getting feedback on like, where are we in the market, blah, 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 blah.
Yeah. A lot of the times our PRDs are internal, but when we share them out, they're really profound. We found the most luck with making a like design decision document that just justified like the decisions that got where we were. Right.
That's much more of the engineering approach. Yeah. And also, because the design decision, that's an interesting thing that kind of pulls into this.
There's an interplay here.
Yeah, because like the feeder PRD goes into some of the research about, well, we tried the optical sensor and it wasn't accurate enough, blah, 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 blah. And we know it needed to be X accurate because of customer interviews. So we decided to do this angle. But then the design decisions gets more into, we do talk about like what people want a little bit in that, but it's mostly engineering architecture stuff. But all of that is still informed by the customer feedback. It should be your North Star for what you are making, full stop. Like I usually have it open as a tab on my Chrome browser kind of all the time. I just have it up if I'm working on that product just to kind of check in every once in a while, sometimes leave notes or whatever. Like It's a living thing. It shouldn't change. They should be immutable, but like it should be actively looked at and referenced all the time.
Yeah. Makes a lot of sense.
Mm-hmm. Yep.
Okay. So you've written a PRD, you've gotten buy-in, there's rubber stamps. All teams agree. Yeah. They're happy.
Yeah.
What now? Right?
Maybe not happy, but in agreement.
Yeah, they're ready.
Yeah. The thing on that paper should make people happy. It should do the thing that it should solve a problem for people.
Yeah. Then it's just time to draw the rest of the owl and like get to actual work.
Yep.
You've hopefully by now had a list of qualitative and quantitative goals to work for, things you can measure your progress against.
Yep.
Evaluate whether your design is going to bring people joy or if there's still things to cook on.
Yep. You still got to cook.
You let them cook.
So looking at the PRD for the Lumen PMP, for the version that we're actually working on right now, some of the constraints that we settled on, and these are not going to be crazy, revelations, but they're still important to have. The bulk of the machine consists of FDM 3D printed parts and off-the-shelf hardware. So this is a constraint that's important for how we make it, and it's important for the fact that we want it to be easily buildable by the community. So this is not up for debate. It has to be these things because it's important to us that the community can build it. And those are the methods. Off-the-shelf purchasing and FDM printing are the ways that they can do that. The machine's API is 2 USB webcams and a single serial port over USB with a standard Marlin REPL G-code interface. That is also an immutable constraint. That is how OpenPMP controls the machine. It is how people are used to using it so far. This is a PRD for the next version. So we're already kind of basing it off of existing machines being out there and existing customer base. The Lumen's control board is custom, including vacuum sensors for sensing pressure at the nozzle tips. Also immutable. That's a feature that we absolutely want. And there is not something out there that is off the shelf that we'd want to use. So we have decided explicitly to make our own. So that is also an immutable part of it. The Lumen PMP should be able to operate in a bedroom setting. So no high pressure air, 240 volt, excessive noise or smell. So this has to do more with the customer. You want to be able to run it in your living room and it's not crazy loud. You don't need an electrician to come in. We say 240 volts, but we mean,
standard wall outlet.
Standard wall outlet. It should be able to work. No, vacuum pressure or air compressor. It should be able to run in a garage or a spare bedroom or something.
Inoffensive.
Yep. The Lumen PMP needs to be easily assembled after removal from packaging. No routing belts. Less than 1 hour assembly time in best case scenario. So this is also about the feedback we got from the V2 kit. It needs to be easy to put together. This is also immutable. We will not ship a machine that does not do this. The Lumen PMP needs to support up to 50 photon feeders. This is another, just like all the other ones, feeders are an important part. That's something customers have said they really want. We've already designed the whole darn feeder. It needs to support that.
It'd be weird to make a machine that uses less feeders.
It would be weird, yes. So these are all pretty plain Jane, We also have, it needs to be able to support 042 components on here. That's another important part of what metric can we hit with this machine? What is important to our customers that we're able to do? So those are just some examples from our PRD of where we settle, just so you have an example of some qualitative metrics, some quantitative metrics. It needs to be quiet and fine in a household setting and not require an electrician. And it also needs to be able to do X, Y, Z. That's kind of the scope of what you need. And I think we have 8 to 10 constraints. It's not crazy, but you just need to know what's not up for debate. What has to be the case.
And from there, we'll figure it out.
Yep. Yeah. Sorry, I'll just shut up. You take us out with that.
I'm just gonna let you sit with that, bud. Better hope that was a good rap. It's all me now.
Yeah. So now it's drawing the rest of the owl. You know what you need to engineer around.
Yeah. So you have what you need. You have it all written up. You know what you need to engineer around. Go do it.
Go do it. Find a way to make that work.
Yeah. Kick some butt. If you want feedback on a PRD, the Lumen PMP server is a great one.
Yeah.
We got some really smart people in there. And I think it would be awesome of us to put out a template showing what a PRD looks like or how it might be structured. So with no promises here, but we're going to try to find the time in the next week or two to get our template out for this kind of stuff, because that's important to y'all.
Yep. Yeah, I think that would be really helpful. Yeah, I have a template that's pretty clean cut. It needs a little bit more, it makes some assumptions about how you and I think about things. So it needs a little bit more fleshing out. But yeah, that'd be cool to put out the template that we use for, making a PRD.
Yeah, I think that'd be good.
Yep.
Maybe it could fit into be a PRD or how a company, starting a company repo.
That's right. Yeah. Yeah. Maybe it goes into that.
Yeah. Steven and I have been designing things together for so long, we can speak in tongues and it sounds arcane to other people.
There's just so many shared, like I want to do an episode on rubber feet, and the phrase rubber feet means something to us, but it doesn't mean anything to anybody else.
Half the time we'll interrupt each other. It's like, Steven, I know what the rest of your sentence.
Yeah, just shut up. I know what you're going to say, dude. Yeah, it's very efficient.
Yeah.
But to the outsider, it's like, what? That was rude. It's like, no, you don't understand it. It's a different.
They love each other. It's okay.
Yeah, exactly. It's a different way to talk.
So of that.
Yeah.
I think that's a wrap.
Yeah, I think that's a wrap.
I'd love to hear everyone's thoughts on this one.
Yes. Do you do a PRD? Do you write one?
No.
I'm talking to people listening, not you.
I'm kidding.
Yeah, I'm curious to see how people do it. Do you bother writing down all the stuff you have to put in there? Do you just kind of shoot from the hip and it's been working for you, or it hasn't been working for you? Like, let us know in the server. There's a link in the episode notes, episode description. Where you can pop in, and I want to hear.
I'm sure we're going to see a thread, but I can't wait to see how people play it and hear about that.
Yep. Yeah.
All right, folks, that's it for this one. Thank you so much for listening. Please don't forget to leave a review wherever you get your podcasts. It helps us out a ton. You can find Opulo on Twitter and Instagram. And please don't forget to check out opulo.io and sign up for our newsletter where we write blog posts and do customer interviews with other folks building open hardware. That's it, and we'll see you in the next one.
Thanks, everyone.
See ya. No, I'm just trying to think what I was saying there. It sounded profound in my head.